Ladies and gentlemen, the shaded area of this figure is 9 minus the square root of 17 square units. Fascinating. Let's prove it. Here we have a square, a triangle, and a circle. We need to find the shaded area, which would be the area of this triangle here. We have the height, but we don't have the base. The base would be from here to here, and we don't know its length. Alright, the first thing we're going to do is draw the radius of this circle, from the center to this tangential point between the circle and the base of the square. Alright, we draw this radius and we get 90 degrees because they are perpendicular. Alright, well now since this is the radius, it measures 1, and the same happens if we draw another radius from here to this tangential point. You'll also see 90 degrees, and it will also measure 1. You will agree that since this is parallel to this here will also measure 1, and the same goes for down here. Because this is parallel to this, it will also measure 1. We don't know the distance from here to here, but we'll call it x. Excellent. Now since everything measures 4, this here would be 4 minus 1 and minus x. Well, alright, and 4 minus 1 gives us 3. 3 minus x is the base of the triangle, but we still don't have much with that, right? Let's continue with this radius here, and let's extend it upwards until we reach this side of the square, like this. Alright, very well. Now since this whole side measures 4 because it's the side of the square, and we remove this small piece from here to here, it's going to measure 3. Very well. Okay? And the same goes from here to here, it will also measure 3. And since this line is parallel to this one here, you'll also see 90 degrees here. Since this is parallel to this one here, this will also be parallel to this one here and also measure 1. Thank you very much. Alright, as the point whole thing measures 4 and we subtract 1, then this part here measures 3. Great, now we can draw a line from here, from this point from the center of the circle to this vertex. First, let's erase this here and draw the line like this, a shape
More
as
than
formed.
one right
We can use
triangle.
the super powerful Pythagorean theorem here to find its hypotenuse, which we will call h. Then the hypotenuse will be equal to the square root of one leg squared plus the other leg also squared, alright? Alright, we have that the hypotenuse is equal. Since both sides are 3, we can say it is the square root of 3 squared plus 3 squared. Alright. Okay, the hypotenuse is equal to 3 squared plus 3 squared. 3 squared is 9 sa imano, anasisineo sa isispat. So here we have 2 times 9, which is the same as 18. We extract the square root of 9, which is 3, and we get that h is 3 times the square root of 2. Magnificent, now we have the value of h. Alright, and that was it. And we're going to replace it in the figure. Here we have 3 times the square root of 2. Excellent. What is this for? Well, let's continue by drawing another radius of the circle to this tangential point between the hypotenuse of the triangle whose area we want to find and the circle. By drawing this radius again, we will have perpendicular lines with 90 degrees between this line and this other line here, which we don't know the length of. This line here, being the radius, measures 1. This line here, since we don't know its length, we'll call it y. Alright, and once again, we're going to apply the Pythagorean theorem, saying that side y is going to be equal to the square root of the hypotenuse squared minus side b squared. Alright, it leads to being equal to the square root of the hypotenuse. Which is the hypotenuse? Well, it's this here. Very well, so we have 3 square root of 2 squared minus side b, which is this side here that we see is 1 squared. Very well. Esya Carla left with it this way, and we have y is equals 3 squared. First, let's put the root. 3 squared, which gives us 9, and the square root of 2 squared, which gives us 2. 2 times 9 gives us 18, very good, and minus 1 squared, which is 1. Excellent. We have 18 minus 1, which is 17. That means, ladies and gentlemen, that 10 is the square root of 17. Fascinating. We now have this measurement from here to here. It's the square root of 17. Excellent. And the measure from here to here, folks, is x. Why? Because we have 2 lines that are tangent to a circle at a point. Look, this line is tangent here and this line is tangent there, and they meet at a point. So they must measure the same. Very good. Alright, so so here we have again a right triangle, and for the last time we are going to use the Pythagorean theorem in this triangle here. We will say that the hypotenuse squared is equal to one leg squared plus the other leg squared. Who is the hypotenuse? The hypotenuse is the square root of 17. It goes up to here. So we have to add the square root of 17 plus x to complete the whole hypotenuse. That leaves us with the square root of 17 plus x. This squared is going to be equal to the leg A, which we will say is this one here, 4 squared plus the other leg, which logically is this one here, 3 minus x squared. Very well, and let's develop this. Here we have the first term squared, which gives us 17, plus the double product of the first by the second, 2 times the square root of 17 times x plus the second term squared plus x squared. This equals 4 squared, which gives us 16 8 times. 16 plus the first square term would be 9, minus twice the product of the first by the second would be 6x, let's put it at once, plus the second term squared, which would be x squared. And look how amazing, we can eliminate this x squared with this x squared here. Let's move what has x to the left side and what doesn't have x to the right side. So firstly, we are left with this term here, 2 times the square root of 17x, and then this term also has x. We're going to move it here, it becomes plus 6x. This is going to be equal to 16 plus 9, which gives us 25, and we just have this term left, which when moved to the right side becomes minus 17. Excellent. Here we can factor out. Look, we can factor out 2x. I is a common factor of the square root of 17. Notice that multiplying 2x by this gives us this here. And to get this here, we need to multiply it by 3. 2x times 3 gives us 6. Excellent. We have 25 minus 17, which gives us 8. And look, let's move what doesn't have x to divide on the other side. To visualize it better, let's change the order here. Let's put the x first and then the 2. So we are multiplying x by all of this here. All of this here is going to divide, then we have x equal to 8 divided by 2 times the square root of 17 plus 3. Very well. And we can simplify this here. Half of 1 and half of 4. And we have, ladies and gentlemen, that x is 4 over the square root of 17 plus 3. Impressive. Let's erase this from here to there to find the shaded area. Let's erase it quickly. Alright, Tarisita, then we have that x is equal to 4 over the square root of 17 minus 3. And we have a root in the denominator. Like all good mathematicians, we're going to rationalize this. Let's erase this here. How do we rationalize? By multiplying and dividing by the conjugate of the denominator. And here we had a plus, not a minus, right? So the conjugate of the denominator would be changing this sign here. We then get the square root of 17 minus 3. We multiply and divide for the same reason. So here we have the square root of 17 minus 3. Very good. And notice that this here is 1. We have the same in the numerator and the denominator. So let's continue. Here we have the multiplication in the numerator. We're not going to change anything. We'll leave it as 4 multiplied by the square root of 17 minus 3. And in the denominator, something very interesting happens. Notice this here is a difference of squares. You will recall that a plus b multiplied by a minus b is equal to a squared minus b squared. It's a difference of squares. And here we have a plus b times a minus b, which we can write as a difference of squares. The first term squared would be the square root of 17. 7 squared minus the second term. Squared minus 3 squared. Very good. So we have that x is equal to 4. Let's leave this here as it is. 4 multiplied by the square root of 17 minus 3. All this over here. 17. The square root of 17 squared simplifies the index with the exponent and we get 17. And minus 3 squared would be minus 9. Very good. 17 minus 9 is 8. right away. Let's leave this simplifying directly. 1/4 of 1 and 1/4 of 2. We get, ladies and gentlemen, that x is going to be equal to the square root of 17 minus 3 all over 2. Alright, sa desising, and with that, we are going to say that the shaded area is equal to base times height over 2, right? This is the area of a triangle. So what's the base? It's 3 minus x, but x is this here. So let's write down the square root of 17 minus 3 all over 2. This is the base, and we are going to put it here in brackets. And then we have the base, which is 3 square root of 17 minus 3, all of it over 2. Base times height, the height is 4, very good, times 4, and all of this over 2. Alright, can we simplify this 2 with this 4? We can do it because we're subtracting a whole number from a fraction. Can we simplify this 2 with this 4? Here we can. Half of 1 and half of 2. Alright, so we have that. The shaded area is equal to, let's apply the distributive property here. Multiplying 2 by 3 gives us 6. And then when you multiply these 2 by this term, these 2 cancels out with these 2. Let's do it all the way through. We get 2 times the square root of 17 minus 3, all of it over 2. Notice, multiply this term by this one here and it gives us this here. And we can simplify here. So ladies and gentlemen, the shaded area is equal to 6. Then minus times plus gives us minus square root of 17, and minus times minus gives us plus 3. Very well. Alright, finally, we can say that the shaded area is equal to 6 plus 3, which gives us 9 minus the square root of 17. And all of these are in square units like we predicted initially. Fascinating. Let me know in the comments if you liked the video, and don't forget to subscribe and give a like so you don't miss upcoming challenges. We will see each other another time. Bye.